So hello everyone, my name is Shivam Agrawal and today I'll be giving the presentation on my project spam email filtering. So spam are the annoying email to customer which have no use, and why this is such a big problem, cause first of all they are of no use to us and they can hide the useful emails. Second, they can be used by malicious attackers to infiltrate our computer using worms or trojans. Third, they can also some kind attacker can use it to perform social engineering and steal our identity. Sometimes even a lot of spam emails can cause the mail servers to crash. Therefore, we want to avoid spam emails at cost and try to like filter them. Now the problem of spam email classification a is a supervised learning problem. In supervised learning in supervised learning we have some data and associated labels, and the data is assigned labels on basis of some unknown function f, and we try to estimate that unknown function f. In our case, the emails are the data and spam or non-spam are the labels, and we are trying to figure out a rule by which we can assign an email as spam or non-spam. So for supervised learning, there are many classifiers, but naive Bayes and support vector machines are most popular used algorithms. So in our project, we'll be using both of these to solve the problem of email spam classification. Now, naive Bayes classifier. So naive Bayes classifier works on the Bayes theorem. So we know that the Bayes theorem is conditional probability of A given B is equals to probability of B given A multiplied by probability of A divided by probability of B. So probability of A given B is called the posterior probability. Probability of B given A is called the likelihood. Probability of A is called the prior, and the probability of B is the normalizing factor probability. So we'll then mention to you the general setup of a Bayes classifier. So we'll have n data points x1 x2 to xn, and we'll have the corresponding labels plus minus 1, or they can be 0 or 1 as well. So we want to learn the distribution probability of y is equals to yi given x is equals to xm. So here yi can be the label plus minus 1, and xm is certain data point. So using Bayes rule, we can write it as the following. Now in the naive Bayes classifier, we make the assumption that all the features of a certain data point have independent distribution, meaning that if xm is a d-dimensional vector, then we assume that the xm1, its feature xm1, xm2, x dash 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 up to xmd are independent from each other. So using this property or this assumption, we can write probability of x is equals to xm given y is equals to yi as product of probability of x is equals to xmk given y is equals to yi, and the k ranges from 1 to d. Now we can substitute this x is equals to xm given y is equals to y probability in the previous Bayes relation and obtain this relation. Now we are only interested in the label or most probable class of the data point xm. So we can just do a argmax over all the labels and select which class is the most probable. So this is the naive Bayes classifier. Now I will move to the support vector machine. So support vector machine are also most popular classifiers, binary classifiers. So we have again n data points and their corresponding labels, and what support vector machine tries to do is it tries to find the hyperplane which satisfied both the classes by the largest margin. That's why support vector machine is sometimes also called as the large margin classifier. and in some cases the data is not linearly separable. So in that case we map it to the higher dimensional space using some embedding function. The embedding function can be like polynomial embedding, or it can be the exponential embedding. Now SVM tries to solve this objective function, which is minimize WTW plus C summation xi i's. So here W is the normal to the hyperplane, and xi i's are the error made by the classifier, and C is an important tunable parameter. So C controls the trade-off between the width of margin of the classifier and the error made by the classifiers. Now usually we don't solve the problem in its primal form. Instead we convert it to the dual form. So the dual form is given below. Now in the dual form, alpha i's are called the support vector. That's why the name arises of the support vector machine. Here k is the kernel function. Now the kernel function allows us to calculate the inner product of two vectors and their embedding without explicitly calculating the embedding. So this is a classical quadratic optimization problem, and we can solve this problem in order of n cube time on any quadratic optimization problem solver. And then for the project we'll be using the following libraries. So numpy is for like faster array reads and writes, and it also provides the 2D array abstraction or multi-array abstraction, which is not present in Python by default. Then we are using pandas. This is for reading CSV files and manipulating the data. Then scikit-learn provide the machine learning implementation of SVM and Naive Bayes. Now we'll do the code walkthrough. Just a minute. Just a minute, we'll do the code walkthrough. Okay, sorry, we have opened the code. So it's in Jupyter Notebook. So first of all, we'll try to install the libraries if not present. So since we have already installed the libraries, so we'll load the libraries. So first we'll load the NumPy pandas, and then we'll load this gensim library, which provides us which is a natural language processing library. It provides us the function for parsing and stemming the data. So we are loading its parsing function. Then from scikit-learn we are importing this count vectorizer. Now normally our data is in the form of text, and for SVM and Naive Bayes won't work on text, so we need to convert them into vectors somehow. So this count vectorizer converts the text into the bag of words format. Now we have multinomial. Now we'll be importing the classifiers multinomial, Naive Bayes, and support vector machine, and then we'll be importing the various metrics called ROC score, confusion matrix, and etc. Here we read and pre-process the data. So here we are reading the CSV file. Our CSV file name is spam.csv. Now it has some unwanted components, so we are dropping these columns, and now when we have the finished data, it looks like this. So v1 has the labels 0 or 1. 0 indicates that it is a not spam mail, 1 indicates that it is a spam mail, v2 column shows the email. Now we'll randomly shuffle the data set and then split the data set into the data and the labels. And now now here we are parsing the data by first converting it into lowercase and then stemming it so that so that it can be efficiently vectorized. Now here we are trying to convert the data into bag of word format using count vectorizer. Now before we perform machine learning, we'll split our whole data set into training data and testing data. So for training data we are considering so the total data is 5572 points. So among those points, we are 4,000 of those we are considering for training, and remaining 1,572 will be considered for testing. So we here we have split it into testing data and training data. So now we are defining another function called print matrix. So this function will take in two arguments, like the true labels and the predicted labels by the classifier, and it will print the different score like accuracy score, precision score, recall score, receiver operating curve, area under receiver operating characteristic, area under the curve score, and the confusion matrix. Since the data in our data set is highly unbalanced, it has lot of non-spam emails and very few of spam emails, so we cannot just rely on the accuracy score. That's why we are printing these score to assess the performance of our classifier. So now we'll fit the multinomial naive Bayes model, and let's fit it. Now if we print the matrix, we'll see that the accuracy obtained by the classifier is 98%, the precision score is 92%, the recall score is 94%, and the ROC AUC score is about 97%. And if we see the confusion matrix, we see that there are only 15 false positives and 10 false negatives. So this indicates that our classifier is like giving us a good performance. Now again we fit the SVM to the training data. Now we have chosen C by doing a grid search for various C values. Now let's fit the SVM, and if we print the matrix again, then the accuracy is 98%. We have a good precision score at 1. The recall score is little bit low as compared to the Naive Bayes, it is 88%. ROC AUC score is 94%. So we see that we have zero false positives and 23 false negatives. So for SVM we have a little bit more of false negative, but I think these are within our tolerable limits. So SVM is also doing a good job of classifying the text. Now we also have a function called predict. So this predict takes input as a text, and it predicts the label. Like is it spam or not spam according to our SVM classifier and Bayes classifier. So let's try and run few example. So this is the email: want 60-70% 80% off on wallet and bag, see inside. And Bayes classifier says it is not a spam, SVM classifier says it is not a spam, and actually it is not a spam. Now we'll see claim one of our free rewards, get 1000 off. And when we run it, so the Bayes classifier says it is a spam, SVM classifier it is a spam, and true label it is also a spam. And now we can see for the other examples as well. So this was our project.